Before the sun rises on Earth, it blazes without mercy on another world. A world that's smaller than some of our moons, yet scarred by time more than any planet in the solar system. This is Mercury, the first planet from the Sun, the smallest, the fastest, and one of the least understood. It has no air, no weather, no moons, no mercy. Temperatures here swing from -180 degrees Celsius at night to over 430 degrees Celsius during the day, hotter than an oven, colder than Antarctica. Its surface is baked, cratered, and ancient, a frozen record of the early solar system, virtually untouched for billions of years. And yet, it has a magnetic field, shrinking cliffs, hints of water ice, puzzles that defy expectations. In this video, we're diving deep into Mercury, how it formed, what we've discovered, and why scientists are still racing to understand this strange, silent world that dances on the edge of the sun. You are watching Astrovault. This is John. Join me today as we peel back the layers of Mercury, a world forged in fire and shaped by catastrophe. At first glance, Mercury seems like a simple place, a hot, rocky ball spinning close to the sun. But beneath that scorched crust lies a mystery that's puzzled scientists for decades. Mercury is unusually dense, denser than any planet except Earth. And unlike Earth, it doesn't have plate tectonics or a thick atmosphere to explain its mass. So what's going on? Data from NASA's Messenger spacecraft, which orbited Mercury from 2011 to 2015, revealed something astonishing. Mercury's core is enormous. It makes up about 85% of the planet's radius, far larger, proportionally, than Earth's. That means Mercury is mostly iron. One theory is that in the early chaos of the solar system, Mercury was once much larger. But a giant impact, possibly with a planetesimal, blasted away much of its outer crust and mantle, leaving behind a metallic remnant. Another theory suggests that intense solar radiation from a young, hyperactive sun simply stripped away Mercury's lighter elements during its formation. But whatever the cause, Mercury ended up with an oversized core and a thin shell of rock, a planetary oddity that defies easy classification. Messenger's radar also revealed something else. Despite the planet's proximity to the sun, some of its polar craters never see sunlight. These deep, permanently shadowed regions are cold traps, and surprisingly, they contain water ice. Detected by reflectance and neutron spectroscopy, this ice is ancient, possibly delivered by comets or exposed by Mercury's lack of atmosphere. And above that massive core, a thin silicate mantle and crust marked by giant fault scarps, planetary wrinkles formed as Mercury cooled and shrank. These faults stretch for hundreds of kilometers, some rising over a kilometer tall. They tell us something simple but profound. Mercury is still evolving. Mercury's surface is a scarred and ancient battlefield, a witness to the solar system's most violent era. Without an atmosphere to shield it, Mercury has been pummeled relentlessly by asteroids and comets for over 4 billion years. And the evidence is written across every inch of its surface. Craters dominate the landscape. Some are small and shallow. Others are vast, multi-ringed impact basins stretching hundreds of kilometers across. But one crater dwarfs them all, the Caloris Basin. Roughly 1,550 kilometers wide, it was created by a colossal impact early in Mercury's history. The force of the collision was so immense, it didn't just create a crater, it sent shockwaves through the entire planet. On the exact opposite side of Mercury, antipodal to Caloris, lies a chaotic, jumbled terrain, as if the planet's crust shattered from the inside out. It's believed this region, called the Weird Terrain, is the direct result of seismic energy from that ancient impact echoing through Mercury's iron core. But Mercury isn't just craters. Much of the surface is made up of intercrater plains and smooth plains, large, relatively flat regions that hint at past volcanic activity. In fact, for much of its early history, Mercury was volcanically active. Messenger data shows widespread evidence of ancient lava flows, now frozen in place. There are also massive cliffs called lobate scarps that snake across the surface. These are planetary wrinkles, the result of Mercury's shrinking interior. As the core cooled, the entire planet contracted, cracking its crust like drying mud. These scarps cut through craters, which tells us they formed after most of the bombardment, meaning Mercury is still geologically active, at least on a slow timescale. And some might be shockingly recent. Based on their sharp relief and lack of overlying impacts, some of them could be less than 50 million years old. It's a paradox, a dead world that's still moving. And it paints a vivid picture of a planet that, though small, has lived a violent and complex life. At first glance, Mercury shouldn't have an atmosphere at all. It's far too small, too hot, and too close to the sun. Any conventional atmosphere, like Earth's or even Mars, would have been blown away by the solar wind billions of years ago. And yet, Mercury does have an atmosphere, just not the kind we're used to. It's called an exosphere, a thin, wispy collection of atoms and molecules so sparse they almost never collide. Technically not a true atmosphere at all, but more like a ghostly envelope clinging to the planet. This exosphere is made up of elements like sodium, potassium, oxygen, and hydrogen. But where do they come from? The answer lies in constant bombardment. Solar radiation, micrometeoroid impacts, and sputtering from the solar wind all knock particles loose from Mercury's surface. These atoms are ejected into space, only to be caught temporarily by Mercury's gravity before escaping again. It's a delicate balance, a kind of atmospheric recycling driven entirely by violence. But the bigger mystery is Mercury's magnetic field. Unlike Mars or Venus, Mercury has a global magnetic field, one that's surprisingly similar to Earth's in structure, though much weaker. That's unexpected. Mercury is small. Its core should have cooled and solidified long ago. Yet somehow, it still has a partially molten iron core capable of sustaining a dynamo, the motion of liquid metal that generates a magnetic field. Messenger confirmed this during its mission, revealing not just the presence of a magnetic field, but one that is oddly off-center, shifted to the north by nearly 20% of the planet's radius. This asymmetry may be tied to how heat flows through Mercury's interior, or to the strange distribution of radioactive elements deep beneath the crust. In any case, it means that Mercury is more geophysically alive than we ever expected, with a magnetic personality that defies its battered exterior. Mercury's bond with the Sun is unlike anything else in the solar system. It orbits at a scorching average distance of just 58 million kilometers, less than half the distance of Venus, completing one full revolution every 88 Earth days. But here's the strange part. A single day on Mercury, from one sunrise to the next, takes 176 Earth days. Why? Because Mercury is tidally locked in a 3-to-2 spin-orbit resonance. It rotates exactly 3 times on its axis for every 2 orbits around the Sun. That means the same regions of Mercury experience extreme heat and long, punishing cold. At noon, surface temperatures soar to 430 degrees Celsius, 800 degrees Fahrenheit. But just a few steps into the night side, where the sun never shines for months, temperatures plunge to minus 180 degrees Celsius, minus 290 degrees Fahrenheit. The difference is staggering and deadly. But Mercury's orbit also helped rewrite the laws of physics. For centuries, astronomers noticed that Mercury's perihelion, the point in its orbit closest to the Sun, was drifting. Not by much, just 43 arcseconds per century, but no known gravitational explanation could account for it. That is, until Albert Einstein introduced general relativity in 1915. Mercury's orbit, warped subtly by the Sun's immense gravity, was the first observational proof that space itself bends near massive bodies. It was Mercury that turned Einstein's equations into evidence. A tiny planet became a cosmic laboratory and changed science forever. For centuries, Mercury was barely more than a moving dot in the sky. Too close to the Sun, too hard to reach. Even today, it's one of the least explored planets in the solar system. That began to change in 1974, when NASA's Mariner 10 flew past Mercury 3 times, revealing a cratered, moon-like surface and uncovering its magnetic field. But it only imaged about 45% of the planet. It wasn't until 2008 that Messenger arrived, eventually entering orbit in 2011. Over the next 4 years, it mapped the entire planet in high resolution, studied its composition, confirmed water ice at the poles, and uncovered clues to its internal structure. I still remember seeing some of those images for the first time. Mercury wasn't just a dead rock. It was strange, dynamic, and full of surprises. Today, Mercury's story is still unfolding. The European-Japanese Bepi Colombo mission, launched in 2018, is en route. It's already completed several flybys, sending back stunning new images. And in late 2025, it'll enter orbit, with dual spacecraft designed to study Mercury's surface, magnetic field, and exosphere in unprecedented detail. We're not done with Mercury, not by a long shot. Mercury may be small, silent, and scorched, but it's a survivor. It bears the scars of the solar system's birth, carries secrets in its crust, and defies expectations at every turn. From its colossal iron core to its ghostly exosphere, this tiny planet continues to challenge our understanding of how worlds are made. And as new missions draw closer, we're reminded that even the most familiar orbits hold unknowns. Because this is Mercury, and we're only just beginning to listen. Thanks for watching. Don't miss our deep dive into the strongest evidence yet for alien life, right here. And if you love cinematic space stories, subscribe. We've got more just around the orbit.